try this again. Phone calls keep jamming up the camera. So we're down here now, and we're going to see what effect all three things, all three, I guess you could call them constants, have at once. The multiplier out here and the h and k. Now, here's our basic parent graph, x squared. And then we've got this one with a 2 multiplying the parentheses. And, I don't have to read them to you. And here's the tables all filled in. And let's draw the three graphs at the bottom. And we'll compare and see what we can learn. Once again, the plain old x squared graph, we have 0, 0, and 1, 1, and 2 squared is 4. 3 squared is 9, and so on. Of course, the mirror image points on the other side. So there's the graph of y equals x squared, or f of x equals x squared. One more time. The g graph, I'm just going to read from the table here, the g graph. -3, we get 28. -3, 28, and that is the topmost line here. And then at -2, we get 14, 2, 4, 6, 8, 10, 12, 14, right there. At -1, we get 4. At 0, we got -2. At 1, we've got -4. And then at 2, we've got -2 again. And at 3, we've got 4 again. And at 4, we've got 14 again. So there's the graph of that, the g of x function. And it's a little wobbly over there, but how many cups of coffee have we had today? I don't know. Then h of x, at -4, I'm sorry, at -3, at -3 for x, we got -4 for y. And at -2 for x, we've got 5 for y. At -1, 6, 7, 8, we got 8. And at 0, we've got 5 again. And at 1, we've got -4 again. At 2, we're all the way down to -19. So that's 4, 6, 8, 10, 12, 14, 16, 18, 19, way down there. And then at 3, we'd be down to -40, which is way off the grid. Okay, so now what general conclusions can we make about these? First, looking at all three of them, only one of them opens down, and the one that opens down had a negative a value, had that -3 out in front. Now, had your teacher done a better job of drawing, you'd notice this one is a little skinnier, narrower than this one. The first one, if we force the issue, we could rewrite this first one as f of x equals +1 x minus 0 squared plus 0, and argue that the a value was greater for g of x than it was for f of x, and that's what made it narrower. What's the effect of the h and the k? Where's the vertex here? It's at 1. The vertex point is at 1 for x, 1, 2, 3, 4, -4 for y. Now notice that in the equation, we have x minus the x value of the vertex, and then you could think of this as plus the y value of the vertex on the outside, plus -4 or -4. So hk in the first instance, looking back at what I forced in over here, is 0, 0. And HK for this one, it's take away 1. And we could call that plus negative 4 on the outside. What about this third one? That plus 1 can be thought of as subtract negative 1. And then we've got plus 8 on the outside. Is the vertex at negative 1, 8 for this graph? Yes, it is. There's the place where the graph changes direction. It is at negative 1 for x, 8 for y. What we take away from this is the important thing about A is A controls whether the parabola opens up or down, and a larger value of A is going to stretch the parabola vertically. It's going to make it look skinnier and skinnier the larger A is, or if you have an A value that's a small fraction, it'll spread the parabola out and kind of flatten it, vertical compression. The H moves the vertex left or right. It controls the X value of the vertex. More directly, if you think in terms of X subtract H, whatever H is, whatever's being subtracted in there, that's the X value of the vertex. Plus whatever number's outside, that is the Y value of the vertex. So put those two ideas together, and H comma K, that's always the vertex. And once you find the vertex of the parabola, and you know which direction it opens, you can get a pretty good rough graph, even if you don't have a graphing calculator. So that's the end of page 2.